Hey y'all, welcome to week 4 of distance learning. This is lesson 1. The last few weeks we have been multiplying radicals. 2 weeks ago we just were practicing multiplying and simplifying them. Last week we practiced multiplying by doing distributive property one day and FOIL the other day. Today we're moving away from that and moving into solving equations that have radicals in them. So this lesson is radical equations, and you'll see right here in the title, it says no factoring, which means there'll be no factoring involved in the solving process. The next lesson for this week, there will be factoring, and we'll talk about that next time. So here are the basic steps for this process. You want to isolate the radical term, raise both sides to the power that cancels out the radical, and then you solve from there. So if you notice, there are 6 problems on your notes. I will do number 1, and then you will try number 4 below. And then I'll do number 2 for you, and you'll try number 5 below. And then I'll do 3, and you'll try 6 below. So the numbers on the bottom are similar to the ones just above them. Now let's talk about this very first step. It says to isolate the radical term. Well, we know from other kinds of solving equations, when it tells you to isolate a term, it means to get it all by itself. But let's talk about what it means to isolate the radical term. That means you look at your equation and you find the piece of it or the portion that has the radical. And in number 1, it's right here. So our first step is to get that highlighted portion all by itself, to isolate it. Well, what is with it right now on the left-hand side of the equation? It's the -9, right? So our first step is going to be to move the 9 to the other side so that the highlighted part is all by itself. So this is step 1. We're going to add 9 to both sides. And now I have left over radical 5n minus 4 equals 9. Okay, so now it's all by itself. It just took me 1 step to get it isolated. So read the second step to yourself. It says raise both sides to the power that cancels out the radical. Well, that radical is a square root. What power cancels out the square root? 2. So raise both sides to a power of 2. What happens here, and the reason why I had to do it to both sides is because it's an equation. So just like we added 9 to both sides here, we're raising both sides to the second power here. And the square cancels out the square root. And what you have left over there is the radicand, whatever was inside the radical, which was just 5n minus 4. And on the right-hand side, we have 9 squared, which means 9 times 9, which is 81. And then the last step is to solve. So this step means now you're switching away from radicals and you're just using your regular equation solving skills. We're trying to isolate the n and get it all by itself. Right now there's a times 5 and a minus 4. Which one do we have to undo first, times 5 or minus 4? Good, the minus 4. I say good, like I'm sure you have the right answer, because I am. I'm sure you have the right answer. So the 4's cancel, leaving me 5n equals 85. And then we divide by 5. 5 goes into 8 one time with a remainder of 3, and into 35 is 7. So I want you to pause the video and work number 4. oops, that's a 5. So you should have m equals 23/3. All right, so now we're going to level this up a little bit. So go back up to the top of your notes for number 2. And look at that equation for a minute and just notice any differences between that equation and number 1 that we just did. Okay, there's a few differences in this problem, but really the only main difference, the most serious one, is that there's a cube root here instead of number 1 where we had a square root. But we'll handle that. So it begins the same. We're trying to isolate this radical term, which means getting it by itself. So we are going to start by subtracting 8 from both sides. So that's step 1. That leaves me with the cube root of 5x plus 1 equals -4. Now step 2, I want you to read that to yourself. I know I already had you do it. I want you to do it again. Do it again. Raise both sides to the power that cancels out the radical, all right? So the radical here has what root? 3, right? It's a cube root. The root is 3. So what power cancels out a cube root? A 3. But you have to do that to both sides of the equation to keep it balanced. So then after the power of 3 cancels out the root of 3, we are left with 5x plus 1 on the left-hand side. But let's think about the right-hand side for a second. We have -4 cubed. Let's talk about what that actually means. It means -4 times itself 3 times. So here's what that looks like. -4 times -4 times -4. Well, if you're following your order of operations, you do multiplication from left to right. So when you do this first set, this first 2, you get +16. Okay. Now times that last -4 gives me -64. So when you have a negative and you're cubing, you will still have a negative answer. That's okay. So now we have this plain old vanilla equation to solve. We subtract 1 from both sides and get 5x equals -65. And then we divide by 5. And we have x equals negative. 5 goes into 6 once with a remainder of 1. And that goes into 15 3 times. So -13. I want you to pause the video and work number 5. All right, hopefully you got x equals -6. The biggest place I could see students making a mistake is right here at this step. -3 to the third means -3 times -3 times -3. And that should have given you a -27. So let's finish out the rest of the notes. We have to level up one more time. Dang it. All right, so take a minute and look at number 3 and notice the differences there from the other two problems. Hopefully you noticed that on this problem, the new thing that's going on is there's a number outside the radical. That's not a root, it's the radical is being multiplied by 3. Okay? So now, step 1 has a few more steps to it. In this case, the radical is right here. Okay, it does not include the 3 out front. So in order to isolate that highlighted part, at some point we will have to divide off that 3 to get it out of the way. So there's two things now going on that's happening to the radical. There's the times 3 out front, and there's the -8 right here. Well, which one do we undo first when we're solving equations? We undo the -8. So that's what we're going to do here. Same thing. Same thing as if there was just a plain variable where the highlighted stuff is. Like this is just a side equation, a side example, but like instead of that highlighted stuff, if we just had, say, an m right there instead, and I had this. So this is the exact same equation. I've only replaced the radical with an m. Right? There's the 3, there's the -8, there's the 4. Well, what would you do to get m by itself? You would start by adding 8. And that's the same thing we're going to do here. But the radical is not by itself yet. It still has the times 3 out front. So what do you do to get the radical by itself? You divide by 3. So we have square root of 3x minus 5 equals 4. And now this looks like the other problems. We have to square both sides to get rid of that radical. That leaves me 3x minus 5 equals 16. Add 5 to both sides. Gives you 3x equals 21. Divide both sides by 3. Gives you x equals 7. I'm going to stop the video and let you work number 6. And then come back when you're ready to check your work with mine. Dang it. So here I have, bless you, babe, bless you, the square root of 4a plus 4 equals 16. I will square both sides. Subtract 4. And then divide by 4. All right, and that's today's lesson. I'll see you tomorrow for the next one.